Question? Yeah. Can you look at page 40? You have that there, page 40, number 13. Let's have a look at it. Albert, stop speaking Chinese, please. Very good. A safe block has 10 digits. On each turn, the owner can turn up to 9 digits left or right. They must turn at least one. So, for example, you have like 4 left, 2 right, 1 left, 2 right. So, each time, how many possibilities? Well, in the first one, you have 9, then you have 9, then you have 9, then you have 9. Because it's for the 4 numbers, which is 9 power 4, which is 6, 5, 6, 1. However, there is one more choice that you can make here. Anyone see what it is? Yeah, the left or the right. So you can start with left and go left, right, or you can start with right and go right, left, right, left. So actually there's an extra choice to make at the start of whether you start going to the left or to the right. So you know with these safes, you turn right and then you turn left. And it doesn't, why does this not make sense? To have 2 rights. So like if I had 1 right, 2 right, what's the problem? Well, that's exactly the same as 3 right. So like if I turn it 1 to the right and then 2 to the right, that's the same as 3 to the right. So for these safes, if you've ever used them, you can only go left, then right, then left. But it's up to you which one you start at. So there's actually 2 choices at the start. So we multiply this by 2, and that's the answer then. That one was a bit tricky. That one was tricky, for sure.
So why is it with no repetition? Because the numbers can be repeated.
They can be.
So
Yeah, it actually would.
got the answer.
Okay, because you could have something like 2 left, 2 right, 2 left, 2 right. That's allowed.
Yeah.
It's not likely, but it's okay. Right, what else? Is there something else? Or does anybody else have another question to see? So Junwei and Tony and Malik.
Malik didn't die with them.
Oh, is he? Okay. Junwei? What time is it now? Sleepy time?
Junwei is a bad.
Yes, I think so. And Tony, do we know? No? Okay. Is there anything else from the book that you need to see? No? No. Okay. We'll have a look at the exam questions. Now, I probably will do these again near the end of the semester. So, I will do these again, but I will do them now as well. So the first one, A1, if you have a look at it. Okay. There we go. This is the days absent, and this is the staff who are absent. 0, 1, 2, 3, 7, 12, 10, and 4. And they want to know what is the mean here. of absences. So which one is the X and which one is the F? That's the first question.
Baby bag.
This one is the X and this one is the F. So you know the formula, don't you? It's the average is the total of F multiply X over total F. So I'll make another column here, I'll call it Fx, which is the two multiplied together. And then I'll get a total F here. So the average will be, oh, and I should get the total here as well. So the average should be equal to 44 divided by 33. Did you get this answer? 1.3? Albert? No, okay. Now, the median is a little bit trickier. How many staff members do we have in total? It's 33. So if you have 33 people, the middle person will be the 17th person? 16 and 17? No, 17th. 17th person, yeah. Anyways, it doesn't really matter. Where will the 17th person be? They'll be here. That's where no. Here. This is where the 17th person is. So the median should be 1. That's what I think. See, I have the answer here. Let me check. The answer is 1. Yeah. Alright, so that's the first question. So that's not too bad. Did you try these? I don't think so. Well, anyways, we'll continue with section A. Can I delete this? Yeah. Right, number 2. You have some heights here. 1.05, 1.13, 1.18, 1.14, 1.16, 1.05, 1.10. I should put them in order. So if I put them in order from biggest to smallest, here they are here. How do I calculate the range? The biggest, yeah, minus the smallest. So here the range should equal 1.18 minus 1.05. So that's the range there. Now you have 7 numbers. Which number is the median? Here it is here. Which is the lower quartile? It's this one. And the upper quartile is this one. So then the interquartile range, that is the 1.16 minus the 1.05, 0.11, which should be right. Yep, it is. Can you see, Leon? Do you need me to make the font bigger? That's okay, yeah?
Yeah.
Right, number 3 now. 4 in every 5 adults own a mobile phone. What is the probability that in a sample of 7 randomly selected adults, at least 3 of them will own a mobile phone? Give your answer to 3 significant figures. Right, so what's the N here? Well, let me write down. We want the probability, what is it? At least 3 have a phone. That's what we're looking for, yeah? So that would be probability that 3, 4, or 5 have a phone. That's right, isn't it? How many is there? 5, isn't it? 7. Ah, 6, 7. That would be the probability that 0, 1 or 2 don't have a phone. So that's the probability that you have less than 2. In other words, we can use the table book. N equals 7, X equals 2, and P equals? No. That's 0.75. 0.2. Yeah, because we're looking at the don'ts. Yeah. So I don't have my table book. I don't think I have my table book. Do I? No, I don't. So, oh great. What do we get? What do we get here? So we have 7. Do we have a 7? Perfect. We have a 7. We have a 2, and we have a 0.2. 0.8520. Yeah. Wait. Did I read it wrong? I must have. Check that again. 7. It is 7, isn't it? And it's 2.
Probability is 0.8.
Yeah, but we're looking at the don'ts, which is 0.2.
Don't is 0.8.
I thought do was 0.8.
It's 5 or 1 mobile.
4 in every 5 have a mobile.
Oh,
Yeah. 7. At least 3 of them will own a mobile. At least 3. 3, 4, 5, 6, 7. That's 0, 1, 2 don't.
the X is 3, right?
The X is 3. Well, it's 2
Because
for the don'ts.
you got count the 0, so 0, 1, 2.
The X is where you stop. You stop at 2. What the heck went wrong? The answer they have is different. Maybe it's possible. Well, their answer is very wrong then. But I feel like it's my mistake. But I can't see where. It is 7 people. I suppose I could always calculate it the long way and see if I get the right answer. So, at least 3 of them have a phone. That's the same as 1 minus 0, 1 or 2 of them have a phone. So, 7C0 mistake? Please do tell me. Did you find a mistake, Leon? It would make me very happy.
I just tried to do something.
0 people. 7C1 power 1 power 7 plus 7C2 0.8 power 2 0.2 power 6. C1 0. And then 7C2 0.8. Wow, I don't know. I just don't know. Let's type it into Excel. Okay, so let's see. First we'll get probability no one has a phone, probability one person has a phone, probability two people have a phone. Do I have a choose function here, the NCR button? Choose. No. I'll just type it in. Can you just type in on the calculator what's 7C0? It's 1, isn't it? 1 times, this is no one has a phone, 0.8 power 0 times, and then 0.2 power 7. That's a tiny number. The next one, 7C1 is 7, isn't it? 7C1? 0.2 power 1 times 0.8 power 1 times 0.2 power 6. And then I need an equals, of course. Okay. And then this one here, 7C2? 21 times 0.8 power 2 times 0.2 power 5. So this total here is that. So then 1 minus this number. So their answer is right, which means like there's something stupidly wrong here. Stupidly wrong. Has anyone spotted the thing that's stupidly wrong here? At least 3 of them will have a mobile phone. 3, 4, 5, 6, 7. That's the same as 0, 1, 2 don't. Help me. There's something so stupid in front of us and we can't see what it is. Wait. Yeah, I got it now. Don't ruin it for me. I got it now. It's the don'ts. If 7 of them have a phone, how many of them don't? 0. If 6 of them have a phone, how many don't? So it's 0, 1, 2, 3, 4 don't. I should have gone to 4. If I look here, if 7 people have a phone in a group of 7, how many don't? 0. If 6 people have a phone, how many don't? 1. If 5 people have a phone, how many don't? 2. This one makes the 3, and then this one here makes the 4. Stupid. Right, n equals 7, x equals 4, and p equals 0.2. And now if we look that up, what do we get? Okay, well, I hope that was a learning experience anyway. Is that what you were going to say?
Yeah.
Good, okay. So, we figured it out at the same time.
I thought that like the probability of 0, 1, 2 is not the same as like just 0, 1, 2 is not the same as 2.
Should have said something sooner.
No, but it's just like
Yeah. Because you were thinking, clearly he knows what he's doing. I'll stay quiet for a moment and see how this plays out. Right, okay, let's have a look at 4 now. Can I scroll down? So anyways, if you correctly do this, you can see that it's a lot quicker doing this than using the calculator. Okay, 4. This is with sets now. What? A, B, and this is 0.4. And you're also told that P, A, given B has happened. Now, does anyone remember the formula for this? A and B over B. And this is equal to 4 over 7. Now, we know what this is. What's this? 0.4, yeah. So PB will equal 7 over 4 times P A and B, which will be 7 over 4 times 4 over 10, which is 7 over 10, or 0.7. So if PB is 0.7, what must this be? It has to be 0.3. Yeah. That answers part A. What's the probability of B? Part B, what's the probability of not B? Probability of B is 0.7. So what's the probability of not B? 0.3. So we know that X and Y together, they should make 0.3, because that's the not B part. Yeah, because here's B, this is, I'll show you in red. This is B, so outside of B, this is the not B part. And the last part is A and B are independent. Find A. So if you remember, independent means probability of A multiply probability of B should equal probability of A and B. So that means X plus 0.4 multiplied by 0.7 should equal 0.4. So this gives us the X is 6 over 35. So we can finish now. Probability of A will be 6 over 35 plus 0.4. So that would be 4 over 7 is for the A. That was question 4, which is correct. That's good. That was a little tricky. Okay, can I scroll down? Yeah, number 5. You have a dice, so you could have 1, 2, 3, 4, 5, and 6. So for 1 and 6, the probability is a quarter. For 3, the probability is a 20th. And for 2, 4, and 5, the probability is k. And we don't know what it is. This is x, and this is p. We could find what the k is, though, because the total should be 1. So 1 over a quarter plus k, plus 1 over 20 plus k, plus k, plus 1 over 4 should equal 1. So 3k should equal 1 minus a quarter, minus a quarter, minus a 20th. So I get k is 3 over 20. That's the first half. So I'll redraw my table now. One, 2, 3, 4, 5, 6. 0.25, 0.15, 0.05, 0.15, 0.15, 0.25. This is x, and this is the probability. Okay. Now the next part is the expectation and the variance. So expectation of x, that would be 0.25 plus 0.30 plus 0.15 plus 0.60, 0.75 plus 1.50, I hope. Well, if I get the right answer, I thought it was okay. I got 3.55. Have a look. Yeah, so that's 3.55. So the expectation of x squared is 3.55 squared. Now we need to calculate expectation of the x squared. So the x squared is 1, 4, 9, 16, 25, 36. So this would be 0.25 plus 0.60 plus 0.45. Okay, I can't do the next one in my head. 0.15 times 16 is 2.4. And then 25 times 0.15, that's plus 3.75, and then it's 12, isn't it? 36 times 0.25, oh no, 9. So this is 16.45, and that one was 12.6025. So finally the variance is the difference between the two. $3.8475, which is exactly right. Good. Okay. What did I ask you to do in section B? B1 and 1 and 2, was it? Yeah. And 4. Yeah. How many people did B1? Yeah. Yeah. No? Say again?
The books at home.
Ah, but did you do it?
No.
Anyone over here? Anyone? You did it, yeah. And anyone over here? Do you try this? Okay, let's have a look at B1. Did you do 1, 2 and 4? 2 was a problem. Yeah. Let me think. Let's give these people who didn't do it at home a few minutes to do it, and then you could try to do number. You should be able to do number 3, but it looks so ugly. It's ugly, but maybe you can try number 3. Yeah, I know it's ugly. It's very ugly. We'll give a few minutes for those people to try. You didn't do this at home, did you, Albert? No. No. Neither did you. And you're good, buddy? No. Okay. So I'll give you... Number 1 was short, wasn't it? How long did it take you to do number 1? 10 minutes? This one was okay? And this one? This was easy, yeah? This one was short. 10 minutes? Maybe less? Maybe more? Yes, okay, alright. So I'll give you 10 minutes to do B1. You want it? Give me a please. Yeah, so genuine too.